arrive at an ATM according to a Poisson process with an average rate of 40 people per hour and individual and divided into 4 types. There is 50% of them arrive to withdraw cash without checking their account. 1 divided by 8 of them arrive to check their account balance and withdraw cash. 1 divided by 8 of them arrive to check their account balance only, and 25% of them arrive to deposit check only. So now we ask, what is the probability that in 3 hours 5 people arrive to deposit a check if it is known that at this time 12 people arrive? So there is 12 people total, and we want to know what is the probability that 5 of them arrive only to deposit check. Remind you, on average 25% of the people come to deposit check only. So we will look at this question as kind of a binomial distribution. So it's really like deposit check, there is 5 people, given that we know that up until hour 3 there is 12 people. So the probability that someone that arrives will deposit check is 25%, which is 1 divided by 4. So from out of 12 instances of occurrence that people arrived, we want to choose 5 of them. Doesn't matter the order. And we want to multiply that by 1 divided by 4, which is 25%, to the power of 5, and multiply by the rest that can choose any spots they want. And this is the answer. So this is kind of a binomial distribution. If you don't know it, maybe check my other videos. Binomial distribution where you choose 5 people with a probability of 25% out of 12 people. And you don't care about the order. Now for the second question, what is known that between 7 and 9, 20 people arrive to check their account? Okay, balance. What is the probability that the 18th person from them arrive at 8:30? So here we look at one of the 2 scenarios. One of them is arrive to check their account and withdraw cash, and the other one is only to check their account. So the total amount of people that do both of that is 1 divided by 4, which is 25% of 40, which is 10%, meaning our rate now will be 10 people per hour arrive to check their account. Now we want to know what is the probability that the 18th person from them arrive before 8:30. So here we look at conditional probability. So we look at this option, okay, this probability, but if you will notice, this probability actually depend on each other, because you cannot say this is 2 independent scenarios. The amount of people that will arrive between hour 1.5 and hour 2 is really dependent on each other. You cannot say it's independent. So we will need to separate it into 2 options. So we will write it that we want to look at both scenarios. So we get the 18th person arrived before 1.5, and there is total, when we know it, there is total of 2 people who arrive, there is total of 20 people who arrive until hour 2. So now I just separated into 2 disjoint probabilities. I need to fix it that this will, whatever number it is, this will be complementary to that. So here I write the full probability, which is the probability that someone will have 18 people before 1.5 hours, multiplied by the probability that in this half hour you get another 2 people, so you get 20 people total. And now we want to look at the probability that you have 19 people before hour 1.5, because it's 18 or more, and that multiplied by the probability that you get another person in half an hour, and plus the probability that you have 20 people before 1.5 hours, multiplied by probability that you have 0 people in this half hour. So this is all the 3 scenarios that can happen in the second question. And now you just need to plug it into this formula. Remember that the lambda is 10 this time. And I just put the numbers in, and I really hope that I put all the numbers correctly, but approximately this is the answer. Okay? If someone put all the numbers in, please let me know if I was right in my calculation, because I feel a little bit dubious about that. So, and now they ask me what is the expected number of all people who arrive between 5 and 3 to withdraw cash. So to withdraw cash, there is a couple of options. So if we look at the first option, half of them arrive to withdraw cash, so we're 50%, and here none of them come to arrive. They arrive also to withdraw cash, and also here. So here they don't come to draw cash, and here also not. So you have half plus 1 divided by 8, which is 5 divided by 8, okay, which is approximately 0.625. And here the expected number is lambda, which is now 0.625 multiplied by 40, so it's supposed to be like that, 0.625 multiplied by, 0.625, and that is, one second, I will tell you, is 25, and in 10 hours, so approximately you get 250 people. So hope you like this video. Please like and subscribe, and please leave a comment below, and if you know the answer here, I did not really bother to put it in a calculator, please let me know, and until next time guys, I'm out.